Hi, I'm Julin. Welcome to my talk about publishing well-formed Python packages. In this talk, I'll mention some ways in which we can make our packages well-formed so that they are easier to work with. But what do we mean by a well-formed package? Well, the main objective behind making a package well-formed is to make its maintenance easier so that we need not spend too much time fixing problems which could have been avoided or at least minimized in the first place had we taken care of certain aspects of our package as we were developing it. A well-formed package is well-structured, well-organized, and follows certain practices which leads to quality code. This will help make things easier for the community that use and develop that project, as it paves the way for smoother collaboration between the members of the community, and there are less chances of confusion creeping in. We can make any changes as we need as per the changing requirements. If you want, we can make changes to such a project in a less chaotic manner because our package is well formed. So how can we do that? How can we make our packages well formed? Sufficient documentation, proper test, and a few related stuff can help. Let's take a closer look. This is an overview of the topics that I plan to cover today, all the way from the linting and styling aspects of the code itself, through static type checking, unit testing, and all the way till the actual packaging and publishing aspects of the package itself. Let's begin with linting and styling. One of the first things that you can do to make your package well-formed is to adopt a suitable coding style and enforce that coding style using linting tools. It's good to have the suggestions mentioned in PEP 8 in mind when you're choosing your coding style because, as we all know, it has got a lot of good suggestions which have turned out to be quite good. So it would be good to keep that in mind. And using these linting tools will help our code achieve a more consistent formatting so that it will be more readable. And of course, a readable code is extremely important in order for the project to be maintainable because as they say, code is more often read than written. So we need the code to be easy to read so that when we read it later on to make changes and all, we will know what exactly it is doing faster so that we can get things done in an easier way. And using linting tools, we can also, these linting tools are also capable of finding subtle bugs that may have crept into our code without us realizing it. For example, like an argument of a function may be having a default value, which is a list. And that's not a good thing because a list is mutable, and while we keep calling that function again and again, the list value will keep changing. So the default argument value will be different that what we may be expecting from the second function call onwards. So the linting tool can help us spot that in an easier way. It will say, hey, this looks bad, you may want to change that. The linting tool will tell us that, and we can make the appropriate changes. Pylint and flake8 are some of the commonly used popular linting tools for Python that we have. The default values are good enough, but if you want to change any rules, they are quite configurable. And there are code formatting tools like Black. In the case of linting tools that we saw earlier, like Pylint and flake8, we would have to run those commands every time we make any change to our code base to see if something is missing or something is going wrong, or the formatting is wrong, things like that. And as time goes on, you may find that you're spending more time than is ideal just to fix the formatting aspect of your code. But if you are okay with letting an external tool take control over the code formatting part of your project, you could use a tool like Black. Black is an automatic code-free formatting tool which takes your code as input and formats them in a way that it thinks is the best. it has its own opinions regarding the idea of a well-formatted code, which is the reason why it is called an opinionated code formatting tool. But Black is useful in the case where a lot of people are working together on the project, and each member working on that project can write their code in a different style. Each one of them can use a different style. But after you run Black on this code, it will just look the same as if it has been written using the same code throughout. It doesn't matter. So we no longer have to worry about the code formatting. Black will do that for you. This means that you can focus more on the code itself than on the code formatting. Another mechanism that can help us make our package well-formed is static type checking. Python had been supporting type annotations for quite a while now. Actually, taking advantage of it not only improves the readability of your code without having any effect on the program execution part, but also allows us to run a static type checks. So in a way, we can sort of combine the advantages of a statically typed language in a dynamic language like Python, which offers us more flexibility as well. So these static type checks can help us uncover bugs and errors, incorrect usages, which would have led to some very puzzling errors. But thanks to static type checking, it is more possible for us to figure it out on our own without actually ever having to execute the program itself. So there are a lot of tools available for performing static type checks in Python code, and among them is MyPy, PyType, and PyRay. Another cause for concern is dead code. As the project evolves, it is easy for it to have some dead code accumulated with it. This dead code may not actually cause trouble at once as soon as it becomes dead code, but will be quite capable of causing trouble by interfering with the rest of the code later on when the conditions are right for the dead code to become active. And this can lead to some unexpected results, the reasons for which can be quite hard to figure out because of the existence of dead code. So to be safe, it's always a good idea to ensure that the project doesn't have any dead code. There are tools available for us which will help us identify the dead code so that they may be removed. We can use tools like PyFlakes and Vultr to identify dead code. Now that we have our project with its style, type checking, and dead code taken care of, we need to verify that the code works as we expect it to work, that it returns the values that we want it to return and accepts the kind of parameters that we want it to accept. So we can do unit testing for that. So testing is one of the main things that make maintenance easier in our quest for making our packages well formed, because we can make changes to selected portions of the code without worrying about its effect, without worrying about it interfering with the behavior of the remaining code. Because after any change, after making changes to some parts of your code, we can run the test for the remaining part of the code to verify that the changes that we made to some other part of the code does not change the behavior of the rest of the code. So it's as easy as running the unit test for those code segments. So we need not worry about some changes interfering with the rest of the code. So this makes actually modifications to the code base way more easier and a peaceful experience. So there are many testing tools and frameworks available for Python, and among them is the built-in unit test, which is a part of the Python standard library, and the third-party pytest. Pytest is quite popular due to its simplicity, ease of use, and rich features. For example, things like fixtures and parameterized test is much more straightforward and easy to learn and use when compared to the equivalent features offered in the unit test module. So let us consider an example for unit testing. So for this example, I'm using pytest, and I have a similar function strcmp as earlier, which accepts two arguments x and y, two strings, and I expect it to return -1 when x is less than y, and 1 if x is greater than y, and 0 if both x and y have the same values. So I will have written a test like this. I passed chicken and egg as the values of x and y to strcmp, and of course I mean strcmp for these arguments to return -1, because that's how it is supposed to work. Yet running pytest on it says that something went wrong. strcmp is not behaving as I expected it to work, because it returned 1 instead of -1. So what went wrong? Let's take a closer look at strcmp. Obvious that what went wrong here, because once we actually take a look at it, these two lines are what is causing the problems. These if statements somehow got swapped. Maybe while making modifications, well, maybe we wrote it right at first, and maybe it went wrong. Somehow the if statements got swapped. But we still think that it is working as we expect it to work. But it isn't actually. So running this unit test will help us realize if something went wrong in between, even if it was working right earlier. So it is important to run unit test before actually releasing your code, before publishing your code, because of such errors that can creep in. So let's fix this and swap these if statements back. So now I run the test again, and it passed. So unit tests are helpful. But having your code tested alone is not enough. We need to make sure that our tests actually cover all the relevant parts of the code that we were testing, because otherwise there will be we might as well not have a lot of test cases anyway. We can use appropriate tools, coverage measurement tools, to see which all statements, which all parts of the code that we missed, and add appropriate test cases as we see fit to cover those parts of code as well. But having good coverage is nice, but striving for literally 100% coverage may not always be worth the effort, because for example, maybe your if main part will only have a call to a function, maybe just one line, a call to a function, which would be being tested anyway. So instead of we need not actually cover that as well, right? We can, because it consists only of a function call which is being tested anyway. So our coverage measurement tool by default will probably say that part of code, that single line is not covered, but it doesn't matter anyway, right? That's right. So we can use, there are many coverage measurement tools available for Python programs, and the most prominent one is probably coverage.py. And pytest also has a plugin, a pytest code that makes use of coverage.py. Which so if you're using both pytest and coverage.py and wish to have want them to work with each other in a more close fashion, maybe you would be better off using pytest code. So let us consider an example to illustrate the use of coverage. I have the same function strcmp here, which accepts two arguments, two strings x and y, and compares them and returns an integer value. I have the same test case which passes chicken and egg as the values of x and y to strcmp. But running coverage test on this test coverage on this function for this particular test set of tests, actually only one test in this set, will say that we have only 50% coverage. And those three lines highlighted in red are not covered by our test. Of course, our test case, chicken and egg, considers the x less than y case alone. We are not testing for the x greater than y or x equal to y cases. So we are out of the 3 branches, we are testing only 1 branch. So if something went wrong on the untested branches, we would not know it because our test cases do not cover it. So that's the use of test coverage. So we add the some extra assert statements to cover the 2 remaining branches as well. And now if you run coverage, it will say 100% coverage. Now we have our unit test ready. We also have some other checks like static type checks and linting and style checks that we need to run on our code base every now and then. And we also need to be sure that our package works properly in all the supported environments. These environments may be running on, maybe having different Python versions, or maybe even different Python implementations. For example, consider the valorous operator, which is available only from Python 3.8 onwards. Suppose that we used it unknowingly in our code base, which was supposed to work even on an older version, like Python 3.6. And if your local system is using 3.8 or newer, running your test on your own system will not show any error because it is okay. The valorous operator is supported there. But if you run it on an older version, it will give you an error. And running our test in all the supported versions every now and then sounds like a lot of work. So we can automate it using a test automation tool like Tox or Nox. But running our test in some certain configurations and package layouts can lead to misleading results. It may cause some test to accidentally pass. That is, the test may not have actually passed, but it will show as it has passed. Let's take a closer look. By package layout, we mean the way in which the files and directories of the project are organized inside the project's directory. There are many possible layouts. 2 of the commonly used package layouts is the flat layout and the SRC layout. In the case of flat layout, the project source code as shown here under the package name directory, and the test of the package under the test directory comes under the same levels, under the same directory level. Whereas in the case of SRC layout, the source code under the package name directory is isolated from the test directory by adding another directory level. It's nested in another directory. Tools like Tox actually create a separate virtual environment to which your package is built and installed, and your tests are actually run in that virtual environment, in that separate virtual environment, not in your own in the pre-existing environment. It actually creates its own virtual environment for you to run those tests. But in the case of a flat layout, if you are using tools like Tox in a flat layout, the Tox will create a separate virtual environment, and the packages installed in that virtual environment will be in that vnlib site packages directory. So your package, the test in your package is expected to import the packages from the virtual environment itself. But if you are using a flat layout, because of the way the Python import system works, it will actually import, the test will import the modules from the source directory itself, instead of importing them from the virtual environment's package directory, site packages directory. So if you're running tests like that, you're not exactly running in a virtual environment. You lose the benefit of running the test in isolated manner in a virtual environment. But if you are running it in a SRC layout, it is impossible for the test in the test directory to import directly from the package name directory, from the source directory itself, because it is separated, isolated using another directory level by placing it inside another directory, like named here as SRC.
So in such a condition, the test would import from the site packages directory of the virtual environment itself and will work as we expect it to work. So that is an advantage of SRC.
There is no officially recommended layout for a Python project. The Python community has not agreed upon a standard layout. You pick the one that you find will work better for you. For smaller packages, you may be okay working with flat layouts. But for more complex packages, especially packages having sub-packages, you are probably better off using SRC layout. You can check out these links to see some interesting discussions about the package layouts and the way this configuration affect the way the tests are run. So once you have your project ready and you're satisfied with its quality and the test all pass, you will want to share your work with others. You will want to package it. So for that, you create a file which can be used to install your module, your project, your package into other systems. This process is called packaging, and the result is a package. There are many tools which can be used to create packages for Python, and that includes the setup tools from PyPA, the Python Packaging Authority, and there are newer tools like Flit and Poetry. So once you have your package built and it is ready for distribution, you can upload it to a server from where others can download and install it. Usually people upload it to the pypi.org server, but it would be better if you are new to this, it would be better to try to upload it to the test.pypi.org server. It is exactly like the actual pypi.org server, except that it is for the test purposes, to see if your package is okay being uploaded to the server, and then we can actually check if installing and downloading and installing from that server actually keeps the package working as we expect it to work. To do the publishing part, you can use tools like Twine. For setup tools, you can use Twine, and in the case of Flit and Poetry, they can do the publishing part as well by themselves. But of course, Twine can be used to publish independent of the package of the tool used to do the package your project. Apart from the tools that I have mentioned so far, there are a lot of other tools you can use for your project. So like a bump version, which can be used to change the version number of your package. If you're using bump version, changing your version number is as easy as running a command. And it can also be used to add tags to your, if you're using a version, Git, you can use tags automatically while you're changing your version. And there's pre-commit, which can be used to run commands like black or pylint every time you make a commit to your project. And there's isort, which can be used to sort your imports in a good manner. And there's cookie cutter, which is especially useful if you're using setup tools to make your project, because setup tools has a lot of files which you need to be set up when you're beginning your package. Going forward, what can we expect? Now the pyproject.toml file can become the center point around which the package revolves. Earlier it just used to be setup tools for packaging, and now alternatives like Flit and Poetry have come up. Thanks to some proposals that have been accepted by the Python community, we now have the option for choosing the build system of our choice by specifying it in the pyproject.toml file. And discussions are ongoing to standardize the project metadata as well, so it can be stored in the pyproject.toml file directly, from where it can be used by the packaging tool of your choice. And because of the toml file becoming more prominent, maybe we can expect a toml module, a module which can parse toml files in the standard library as well. So now we have come to the end of the presentation.
Let's have a quick recap of what we saw so far. So we talked about linting and styling, and static type checking using tools like MyPy, and eliminating dead code. Identifying dead code, and so that it can be eliminated later by using tools like Vultr and PyFlake. Then unit testing, test coverage, and test automation, and finally packaging and publishing. So that's it. Thanks for listening. And if you got any questions or suggestions, I'll be happy to listen to.